Okay, this is the P3 paper from October 2020. It's question number 4. As you can see by looking at it, it's a modulus question, functions and graphs, but it's a modulus question. We've got some solving modulus problems in here, and the last part we've got some combining transformations. Only worth 8 marks, and yet a really tough 8 marks to find. If this was me doing this under exam conditions, I might do the first 2 parts, but then I'd jump past the last 2 parts and come back to it at the end. But we're not going to do that now. We're going to get started and actually do it. Part A says find f(f)(6). Okay, so part A. My function is given by fx equals 21 minus 2 modulus function 2 minus x. So what does ff6 means? ff6 means find f6 first, get a value for that. So it works out to be 10. I'm going to do f10 for my second bit. But obviously, first of all, what we need to do is to work out f6. So f6 is just putting 6 into the function. So I end up with that. I'm going to quite quickly do this, but basically that's minus 4. Modulus of minus 4 is 4. 2 lots of 4 is 8. So I've got 21 take away 8. That works out to be equal to 13. So what I just said a second ago was ff6 then is f13 now, because we know what f6 is. So that means just sticking 13 into the function, 21 minus 2 lots of 2 minus 13. And again, I'm going to do it really quickly. That's minus 11. Modulus of that then is 11. 2 lots of 11 is 22. So 21 take away 22 gives me minus 1. And that first part is done. So that's relatively straightforward. Second part just needs some thinking about. So we're asked to solve the equation fx equals 5x. Right, okay, graphically, if I'm solving fx equals 5x, what I'm doing is drawing out y equals 5x and then saying where the 2 lines meet, that's where we're going to solve the equation fx equals 5x. And quite clearly I can see, even though this is a sketch, there's only going to be one answer. Right, so alongside that then, what I need to understand is that this is my function 21 minus 2 modulus 2 minus x there. And if I've got that situation, I've got 2 parts to it. One where I've got a positive gradient there and one where I've got a negative gradient there. How does that look algebraically? Well, let's just have a quick think about that then. So a little bit of teaching here going on. What I can consider is if fx equals 21 minus 2 minus x here, what's happening to that algebraic, so that graphical bit here, is there will be times when 2 minus x is positive, and there'll be times when 2 minus x is negative. Well, when 2 minus x is positive, this function could be thought of as being, fx could be thought of for positive, could be thought of as being just 21 minus 2 and just brackets 2 minus x there. The positive doesn't make any difference at all. So if we work that out, what's that going to look like? That's going to be 21 minus 4 plus 2x. That's going to be 2x plus 17. Okay, the graph y equals 2x plus 17 is this graph here. And what that does tell me, which I will use later, so I'll put it in now, is that value there is 17 and it's a positive one. If we now consider the situation where we had a negative, and I mean that there's a negative in there, 2 minus x works out to be a negative, well then the modulus sign is having an impact and we're actually getting the negative of what we want. So then fx would be 21 minus 2, so plus 2 minus x, and that would give me a different function. That would give me 21 plus 4 take away 2x. That would give me 25 minus 2x, or rather minus 2x plus 25, only if I was thinking about what the equation of that line there is. And we can see that is a negative gradient, and it makes sense that if that got extended up there, that would be 25. So yeah, that all fits in. Well, that's really helped me now, because I could either solve this one equals 5x or this one equals 5x, but I know from my sketch there that I'm looking at where it hits the negative line, so it's going to be this one here that I'm going to solve. So that's really helped me to now say when I'm finding that one solution only, I'm going to do minus 2x plus 25 equals 5x, which is going to give me 7x equals 25, x equals 25 over 7. That now means, don't need those two bits underlined, that now means that I've solved that second part there, just the single solution. Okay, moving on, and as I say, this is a tough question for the marks. I don't mind difficult questions, but I want a few marks for them. This is part C, and it says, okay, now we're given the equation that fx equals k, where k is a constant. It has exactly 2 roots. What can k be? Right, go back to our diagram. Let's just get rid of this for a moment because we don't need it. It's just going to get in the way here. We'll leave the 17 in there though. If I want to find where fx equals k, well, when I wanted to find where fx equals 5x, I drew 5x out and then found where they met. So what I've actually got to do is to draw y equals k on, and then find out where that meets fx. Well, we expect you to know what y equals k looks like. Y equals k is just going to be a horizontal line which goes through at k. Right, now I'm beginning to get what they want then. If you go back and read the question again, so down here it says, where does it have exactly 2 roots? So as I move k can move up and down here. As k is up there, it's all like 30 odd. There's no solutions to where the 2 lines meet. If I come down to that point there, then that is going to be a key situation because there's only one value there, but everything below that, but above 17, there are 2 solutions to where the 2 lines meet each other. Okay, and those two solutions will continue to go all the way until I get from that value there all the way down to that value there. And at that point there, those are going to be where my 2 solutions are. So if I just put those 2 sort of like train tracks on there, k can be anything inside those 2 values. So we know what the minimum one is. The minimum one is 17. What I need to do is I need to work out what that value there is. Well, that value there is just the maximum value of 21 minus 2 lots of 2 minus x. So let's talk about that now then. This is part C. For maximum fx, well, what is fx? Fx is given by 21 minus 2 lots of 2 minus x here. And we can see then, just common sense, it's only worth a couple of marks, remember, that if I put x equal to 2, I get that f2 is 21 minus 2 lots of the modulus of 0, which means I'm not taking anything away from 21, which means I get 21. That has to be the maximum value. Any other value you put in, you'll get, whether it's positive or negative, a value inside the modulus, which means I'll then be taking something away from 21, which will mean it'll get to be less than 21. So just take a little bit of time to think about that. The maximum point is 221. And more importantly, that value there then is 21. So when I'm trying to work out what k is going to be now then, So K basically can take anything between 21 and 17. Just stop, I haven't quite finished this yet. Do I mean including the values? Yes, I include the value of 17 because there are two values there, but I don't include the value 21. Let's just go back to the graph. When I'm talking about at 17, there's two values, 18, there's two values, 19, there's two values, but when I get up to the 21 there, then that's the topmost point, there's only one value there. Right, told you this was difficult for all the marks. We've now got to do the last part, which doesn't really get any easier when we're looking at it. It says the graph with y equals fx is transformed onto the graph with that equation, and then it talks about the vertex of that new equation being 6, 3, and asks us to work out what A and B are going to be. So, not easy. Just stop and read that through again before I get going with doing this. So, part D, what it says is we've got this new graph, y equals A lots of fx minus b, and that as a result of that, we know that 221 will be transformed to the point 6, 3. Okay, so what we're really saying is, what does this do to a graph? Well, let's split it up into the two parts. First of all, what does f of x minus b do to a graph? F of x minus b, this is a fairly standard transformation. F of x minus b is going to be a shift 4 units to the right. B units to the right. I'm doing the answer because I've already worked out what the answer is. B units to the right, or would be a translation B naught there. So if 221 went to 6, 3, I know that B has to equal 4, so that the graph has moved from 221 to 421. That's what it would do first of all. It would move to 421 before I worry about what the A is going to be doing there. Remember, this is only worth 2 marks, so we really only need to give the answers to these 2 bits. And then what does A fx do? Well, A is a stretch scale factor A parallel to the y-axis, isn't it? This is all just functions work. And so what that's going to do is that's going to have the impact on the 21. So the 21, in effect, is being multiplied by something. But if it ends up at 3, then the thing it's being multiplied by is a fraction. Okay, 3 is 1/7 of 21. So that means, again, then, that A is going to be equal to a 7th here, because it's going to make it 7 times as small. It was 21 and it's now gone down to 3. As I said to you, really tough for those last 2 marks. That one was okay, but those last 2 marks there, difficult question. Examiner must have been in a bad mood when he did it, but hopefully, you might need to watch that video a couple of times. Hopefully that makes sense.